Good afternoon, morning, wherever you are. My name is Henk Häusler. I'm the director of the ARC Center for Next Gen Architecture Manufacturing. Before we start, I would like to acknowledge my respect and acknowledge the Bedegal people who are the traditional custodians of the land on which the meeting takes place, and to the elders past and present. It's a great honor today to have Dr. Seungkyu Yoo, a research professor at the Center of AI Technology in the Construction at the Hanyang University in South Korea, with us today. Since 2014, he has been leading national R&D projects in the field of additive manufacturing and making real business cases. His work focuses on facilitating construction, 3D printing research, and business development, with a special emphasis on the freeform facade systems via various additive manufacturing technologies. Example, metal, polymer, powder bed fusion, binding jetted. He also has been developing the business of practical application as follows: metal node system for freeform building facades, polymer node systems for private space structures. So Seungkyu and I had a meeting a few months ago, and we just talked about the research we do here at the Arch Menu Research Center on 3D printing, on digital transformation of the industry sector. And when he presented his work, I thought he would have been a perfect speaker for our Arch Menu lecture series. So we're very, very grateful to have Seungkyu as a guest today. Presenting, we will record that session as well and make it publicly available at a later stage on our homepage. So Seungkyu, welcome to UNSW's Arch Menu, and over to you.
Okay. Thank you so much for the long kind introduction and inviting me to this talk series event. I really appreciate Professor Hank. Personally, I feel extremely honored to present in front of experts from Arch Menu, UNSW, academia, and industrial partners. Could you please send me the authorizing? Yeah. I can. Yeah.
Okay, so we can hear you now and we can see the presentation. Perfect. Thank you.
That's why.
Okay. Thank you. Yeah. Thank you so much for the long, kind introduction and inviting me to this talk series event. I really appreciate Professor Hank, and personally, I feel extremely honored to present in front of experts from Arch Menu, UNSW, and academia and industrial partners. My name is Seungkyu Yoo. I'm a research professor at Hanyang University in South Korea. Today, I'd like to share my experience regarding two different business cases. The first one is a typical order-based business, like a subcontractor, and the other is a totally own developed product business. I propose of this. The purpose of my presentation is to know how to figure out the additive manufacturing needs in the construction industry. Let's move on. Okay, 11 years ago, I was a PhD candidate in construction management. I heard 3D printing technology from President Barack Obama of the United States. He motivated me. He said 3D printing has the potential to revolutionize the way we make almost everything. At the time, I studied the futuristic architecture components and its manufacturing process. I was surprised because finally I found the manufacturing solution. I saw 3D printing is one of the possible solution for making brand new building components which have never seen before functions and freeform shape, and soon began to have doubts. There was no appropriate 3D printing method which matched the construction industry scale, price, and performance. I struggled searching for the right additive manufacturing method, and I also creating best practice until now. I shouldn't have heard Obama's speech. Yeah, yeah. Here are my older research outcomes. Uh, I spend a lot of time and effort to create a proprietary manufacturing systems and their possible design under the technology adoption scenario. As time passes, I moved my position to CTO of a startup company for realizing my things, and my mind changed to creating value based on the needs of customers or designers, designers like a businessman, not an academic researcher. Because I was thirsty for making things, not a rendered image. That's enough. Here are my latest works. I have experienced various additive manufacturing technologies, including binder jetting, powder bed fusion, material extrusion, bed polymerization, etc. I focus the way most effective and fastest approaches. I developed new design process for making concrete products. As you can see, this table, topology optimized the table, and I discovered a new business opportunity in facade sector like this. Additionally, I conducted research on hybrid additive manufacturing system with ETHG DVT. This is a digital bundle project, and oh sorry, and uh, I developed a general product for architecture and pharmaceutical and semiconductor industries. So these experiences continue to accelerate my research and drive real business without industrial boundaries. I think architecture industry, our industry, is one of the largest blue ocean any other industry. There are so many undiscovered business item or research item. Yeah, welcome to construction 3D printing world. Let's get to the point. I'd like to show you Gwangju Galleria Department Store project and the BLOBEE project, which has common features regarding structure nodal system. Additionally, these cases using different additive manufacturing technologies. Let's move on to next page. Let's talk about Gwangju Galleria Department project. Before I tell you this project, I would like to share some pictures. Yeah, just a side thing. Yeah, this is Great Court of British Museum in London. Yeah, look at this amazing long span and the smooth covered ceiling. Looking good, isn't it? I've been I've been there in my honeymoon, and This is my shopping mall in Frankfurt, Germany. As you can see, this penetrated front facade surface makes you feel fantastic. And here is for a mall at Bratislava, Slovakia. Look at this. It is like a tornado. And last one is here is Westfield White City in London. And look at this. Covered envelopment makes great looking like an ocean wave. Let me explain common features of mentioned cases. A conventional nodal system has smooth curved facade and highly optimized tri-mesh by engineers. And the second feature is the almost structured node made by subtractive manufacturing, and sometimes milled and waterjet cut and since milled and welding and bolting, etc. Yeah, we found a new opportunity. Conventional nodal system is how to make a radical surface. Let's move on to next page. Yeah, the Gwangju Galleria project is designed by OMA, located in Netherlands. Look at this amazing render image. Yeah, it seems like a natural granite stone, which has crystal. Client is Hanwha Galleria, which is the most luxury department store brand in South Korea. It is a small scale model. The crystal covers the whole building like this. It makes people work around whole department store. I think it is totally logical design. Generally, in South Korea, the department store facade must be completely closed so that customers cannot feel the time. Yeah, it makes you stay with your wife, and then your wife buy more products. Yeah, just accept it. And here are a fascinating feature: extruded passage. It makes your child surprised. Of course, I was surprised too. Uh, I don't know how to make it. The problem is here. This is a geometrical issue. Typical facade nodal system like a smooth curved facade have narrow ranges for U, V, and W angle. U angle means the angle between beam member. V angle is vertical angle of node normal, and W is a torsion angle. Conventional nodal system has a low degree of freedom under the not optimized tri or quad mesh. Let me show you the result of V and W angle analysis between glass panels. The total panel amount is 1,862. Conventional system can make it between 150 to 210 degree, but 35% is out of range because this project doesn't have a smooth curve and optimize the tri-mesh. And here is a result of U angle analysis. If inside angle decrease, it occurs interference between beams. To avoid this situation, we have to stretch node arm. And this project has not optimized the tri-mesh, so there is a lot of multi-node arms, 7, 8, 9, 10, as you can see. If node arm increase, size of node getting bigger and bigger. It is very big issue regarding the node weight. This slide presents a reviewable alternative nodal system. The initial alternative is the board node system, left one, which encountered several issues, including degrees of freedom and quality, design quality, and workability, and manufacturing efficiency. One critical issue is the misalignment between the center line of the submember and the glass joint line. Definitely, poor outer and inner finish and glass panel procurement problem would be occurred. Think about it. Yeah. Each glass panel size must be measured individually and ordered after completing one triangle structure. You know, as I mentioned there are total of 652 glass panels. Yeah, we can do that. Anyway, the other potential alternatives, such as a cylinder and plate types, has limited degree of freedom. In contrast, the 3D milled node type has the potential to achieve high surface quality, like a body mold, tornado surface, achieve high quality surface, but it suffers from low workability and efficiency and economic feasibility. So these alternatives are rejected by client, and last survivor is also rejected by ourselves. Yeah, we made the layer, yeah, sustainable block model because it is too heavy, ugly, and expensive, and it cannot match the delivery time. It just has 4 node arm. Yeah, what should I do? There is no time. Here are 7 types of additive manufacturing technologies. There are various familiar images, isn't it? So in 2018, it was difficult to find meaningful references regarding the facade system by using additive manufacturing. So, firstly, I considered powder bed fusion technology. As you well know, PBF, powder bed fusion, can make the most precise product, but the cost and delivery is not suitable. Very expensive, as you well know. And also, it is too small to print our nodal system. This video is captured on the XY plane. And secondly, I consider it a direct energy deposition often called direct metal tooling. It could be made large size, but too slow. Oh, oops, sorry. And lastly, I reviewed the wire arc additive manufacturing by using cold metal transfer welding process. It also could be produced larger sized node, but the surface is very rough. It can be matched uh, 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 by inspection. Let me summarize above mentioned consideration. Yeah. X-axis is part size and y-axis is design quality, part quality. PBF is positioned high quality and small scale area. And DMT, direct metal tooling, is under the PBF. And when wire additive manufacturing is covered low quality and big scale area. I need the gray coloring technology. Let's consider unit cost. Y-axis change it into unit cost. PVF is here, positioned expensive, and DMT is under the PVF, and WEM is cheaper than any other. I also needed the gray colored technology, and we need suitable mechanical properties also. Suddenly, a very good idea crossed my mind, not a direct manufacturing approaches. What if we employ an indirect approach, like a sand mold for casting iron? Here are several things points. It provides better access, suitable resolution, and affordable cost, and high capacity, and fast delivery. And we can choose various casting materials. And then I made it. It is called smart node, which has a hollow structure. And it is final winner of competitive building in Galleria project. And key features are as shown. It is steel casting node by using binder jetting sand mold, and also has high degree of freedom, and it has perfect finishing as a seamlessly integrated design. We can make it lightweight node via hollow structure and high precision, fast delivery. Last one is, yeah, you end up cheaper than subtractive manufacturing. Okay, I'd like to show you how it makes. Please look at this video. Node designed by parametric design, and then we design mold and send the mold printed, and then casting iron and depowdering, and we can create any types of smart mold system. There is no same shape. Here is summary of manufacturing process designed using parametric technology and casting simulation and cast method design and printing, mold printing and casting and steel casting, and then post processing like shot pin and heat treatment, and quality inspection. We utilize the 3D scanning for ensuring their size rule, size inspection, size specification, and the other is non-destructive testing method. And done. Here is result of finite element method. Structure stability is compound under the all load case, self-loaded, seismic, and wind pressure. We have to prove this system through visual mock-up tested for getting bidding. So we have made several nodes on-site fabrication by bolting and welding, almost finished it and done. At that time, OMA chip designer and his colleague said, "Yeah, amazing and perfect, and wonderful." And then general contractor said, "Go ahead right now." And he said, "We don't have much time. I will give you 8 months here. I will give you 8 months. You have to make 425 notes." And I said, "Really? Yeah, we need more time." But uh, and then he said, "We are in end game now." So here are node specifications by node arm. As you can see, node arm number of node arm increase, uh, the size getting heavier and bigger. Oh, sorry, not now. Uh, here are superheroes, uh, the heaviest and lightest and longest one. I often call it dolphin. Looks like it seems like dolphin bag. Anyway, my partner company and I have worked day and night. Fortunately, the fabrication site nearby construction site just across the 8-lane road. Yeah. Here is time lapse. Please watch. So as you can see this visual mock-up, and then they confirm they ordered 425 nodes, detached and structure and HB structure getting higher. We utilize the 3D scanning process for matching the for the minimize the construction tolerance of fabrication or on-site lifting and attach the facade module. We're lifting the part module for facade one by one, and then we check the glass panel size, and then we can easily order to Chinese glass company, and we can match the uh, construction duration. As you well know, the department store project is most important thing is the construction duration because yeah, as you well know, department store sales is very big one day. So the client don't want to delay the construction process. Yeah, and done. Look at this amazing facade. Beautiful, isn't it? Yeah, I've been there. Yeah, 3 or 5 times. It is front side and right side, and here is the corridor. Yeah, here is a Samsung store. Look amazing. Yeah. So let's move on to the next topic. I'd like to share another product project. It is called BLOBEE, like a blob. Uh, the BLOBEE project is originated by this question. This is not an order-based business like a Galleria project. This is just product for general consumer. My colleague and I intended to provide never seen before space experience based on learning from Galleria project. Let's think about preferring the curved surface to a cover. It could be tessellated by some tool, grasshopper, etc. using cloning algorithm, and we can make panels easily. If you want to make a structure line, just offset based on the average normal vector between panels, like this. The offset lines doesn't meet same topology. It seems like the normal surface, but it is twisted, not a surface. It is a geometric problem caused by low degree of low degree of freedom. Anyway, we can make beam member. As you can see, the beam members are interferences and cutting out interference in the part, and then connect and then connect to each side of profile, and then patch cover the surface. And how should we or I make it? I called 7 technology is again. In this project, I employed direct additive manufacturing for making final product. Polymer powder bed fusion, not a method. Here are strength points. First one is stable material properties and high capacity and fast delivery, good resolution. And last, relatively low cost. That you, this video is showing the printing process. The PA polyamide 12 powder is layering material, and the other catalytic ink is printed along the uh, yeah surface. So I utilize the HP multi-jet fusion machine. So as you can see, this material on this system can make a suitable product. Flexure strength is 65 megapascal, and tensile strength is max 48 megapascal. Really good. And additive manufacturing is quite good tool for engineer or designer. We can design a lot of connection details, inside design or outside design, and surface texture design, and mechanical part design. Everything we can design everything as you want. Here are connection details. We choose the right side for making seamless structure. We built uh, a lightweight structure for making uh, easy to make freeform interior surface. It is lightweight structure for facade, and then we've made a brand new product, BLOBEE. BLOBEE is a user customized space that can accommodate our customer design needs. BLOBEE can provide a never seen before space and outdoor experience via additive manufacturing technology. Here are specifications of BLOBEE. We employ uh, uh, 33 node and 75 profiles and 43 panels, polycarbonate panel. It can be changed the glass panel. This product was developed for use in premium lounge and outdoor dining room and private space. Its cost is uh, uh, 50, 56,000 Austrian dollar maybe. And we intended pavilion and private fine dining room and hotel meeting room or lounge and the shelter on golf course. And the other is hard type tent, not a soft tent for yeah for camping people. So there is no welding process, just bolt on, and you are good to go. This product can be installed in just one day through digital fabrication technology and foundation fabrication, structural profile assembly, and body assembly finishes, and glass panel fitting, and finishing aluminum cap installed, and then finally customized door and window is installed. So let me show you promotion video. Yeah, powered by HP. Thank you, HP. I said too much. HP multi-jet 3D printer. Yeah, it is. It just ordered from the HP. So here is advanced adaptive node system for facade. BLOBEE system, adaptive nodal system, can make automatically, uh, yeah, facade by using parametric design. And PA12, polyamide 12, is good for lightweight structure system. It has good enough structure performance. Okay, we validated the structural performance via FEM analysis. The structural stability confirmed under the not a normal condition, extreme condition. Yeah, max wind velocity and max snow weight. Yeah, we input this parameter and we analyze this process, and the node stress is less than 50 megapascal in the strength. Let me show you fabrication process. It is making film. Yeah, we install the foundation, modularize the foundation, and fabricate the profile and joint one by one. And then install the door, and as you can see, the glass panel or polycarbonate panel will be installed. And lastly, capping and sealing and finish it. Okay. Here is Jeju Island, which is the most popular travel place in South Korea. It is a showcase for customer. How wonderful scene it is. So white one and black one. And black one intended outdoor bar style, and white one is intended luxury outdoor camping for normal people, for camping life. I drank in BLOBEE last year. So here, this case, here is a rooftop of Mondrian Hotel in the center of Seoul. The Mondrian Hotel is the most expensive hotel brand in South Korea. They are using my product in very interesting way. You have to order Dom Perignon champagne. Yeah, this is the rule. Recently, they are changing spritz brand. I was very happy to see it used in unexpected ways. I tried it once, but it was too expensive for me. Yeah, here is BLOBEE Forest, which is my investor and I developed this whole project. We planned the outdoor luxury BBQ space in Jeju Island. We had to prove the feasibility of BLOBEE for real business application, not sell just the structure. We have to prove the business feasibility. This place is getting hotter now. and I show you some movie. Sorry. This is a YouTuber review video. Yeah. Yeah. There are 7 or 8 BLOBEE system, and the spherical system is also developed by me and my colleague, not using additive manufacturing. Okay, okay. Okay, and the other customer is National Arboretum. So you can see this lobby, and here is a Kids Education Center, forest story and ecosystem. Yeah, look at this. Okay, this is end of my presentation. Let me close now with a lesson from my experiences. Over the past 10 years, I put a lot of thought into developing additive manufacturing applications. And most designer and engineer didn't even think about why they should use this technology. Furthermore, normal people never think about it. So I jumped into on-site myself. I was planner, designer, manufacturer, on-site worker, and salesman. I've got 3 lessons. The first one is to start from the consumer's essential needs, like their joy and happiness. Yes. And second is to clarify the limitation of conventional technology in target product. And last one is prove yourself, prove myself. Design it and make it and sell it. And through this, we can not only consumer interest, but also encourage participation from designer and engineers. Then material, machine, and software will be followed naturally. Okay, thank you very much for your attention and time. If you have any question, I will have to answer them. Okay, thank you very much.
Well, thank you very much for your presentation. I think it was really, really interesting. Before I'm going to go into question, I want to see if there are kind of questions in the audience. If you got a question, unmute your microphone and ask a question, or if you feel more comfortable, put a question into your chat, and I could ask the questions for you. So maybe, is there a question coming up? I see Gavin got his hand up. So Gavin, please unmute your microphone and ask a question.
Sure, no problems. Thank you. It was a very interesting presentation and some really great outcomes on projects as well. I was curious, a lot of the projects obviously seem to fall into more of a luxury lifestyle, a high end, of the market. I'm curious if these types of techniques have the, the realistic capability of reaching, a more social mass level of use, or if they're more well suited to bespoke, high budget, complex projects, and if maybe there's barriers as to why, if that's the case as well. Yeah.
Let me translate this. 그래서 지금 이렇게 보여주신 연구나 프로젝트들은 주로 이제 하이엔드나 이러한 어떤 예시들을 많이 보여주셨는데요. 이제 이러한 하이엔드 예시 외에도 조금 더 일상생활이나 이렇게 양산되는 어떤 그런 일상생활에 투영될 수 있는 이러한 어떤 프로젝트들의 경험도 좀 있는지 이런 것들에 대해서 좀 들어보고 싶습니다.
네. Okay, very good question. Thank you for your question. And the end of my presentation, and BLOBEE is targeted to make affordable structure. Yeah, just it looks like a atypical freeform design. We targeted to reach the low cost structure for every people. So, and the other is the BLOBEE Bambi or B-Star, and spherical on spherical structure. End of my presentation, it is targeted to more cheaper than the BLOBEE system by using the just the digital fabrication CNC milled product. So, in my experience, every freeform structure, everybody wanted to see it, but everybody we have much money for buying the cutting edge or and futuristic design the product. So in my think 80% of people wanted to just appropriate the shape and low freeform the product could be fitted to them. Yeah. So I changed my mind first 10 years ago, and now I smoothly changed it into the cheaper structure is better than the high expensive structure. Yeah. Is it clear to your question?
Yes, definitely. There's obviously some optimization that the product brings with time, and I guess it's just a social transition into these types of construction techniques being more readily understood by the market. But thank you. Yeah.
Okay. Thank you.
Are there any other questions from anyone in the audience? Then maybe I'm going to ask one question. Again, thank you for your presentation. I think what fascinates me really is your transition from being an architect and academic to being an entrepreneur and a salesman and developing a product, because the need to do what you wanted to do required you to become an entrepreneur, salesman, and a product developer. Do you see a future for architects or for researchers in this trajectory of going into, offering a product and developing a product? And what insights or obstacles could you share in that pathway?
Let me translate this. 그러니까 이분께서 이제 하시는 질문이 이제 굉장히 이제 그 유승규 박사님이 이렇게 활동하는 액티비티나 이런 것들이 굉장히 영감을 많이 받으셨다고 했어요. 그 이후에서는 이제 아카데믹으로서 이제 그 학계에서에 대한 이해가 많이 있는데, 이러한 것들을 이제 구체적으로 실현하기 위해서는 이제 또 사업적인 어떤 이런 활동을 사실상 해야 하는데, 이런 것들을 통합적으로 다 다루고 있다는 인상을 느껴서 굉장히 흥미롭다고 느꼈습니다. 그래서 본인은 이제 아무래도 교수거나 아카데믹이기 때문에 이러한 어떤 엔터프레너십, 이런 어떤 사업이나 이런 것들에 대한 이해, 이런 것들이 흥미로웠던 것 같아요. 그래서 이러한 배경에서 이제 주요 질문은 혹시 이제 이러한 것들이 이제 시도하거나 하고자 하는 학생들이라든가 혹은 교육자라든가 이런 사람들이 할 때 방해가 됐거나 장애물로서 있었던 것들이 어떤 게 있었는지, 또 어떻게 이렇게 조금 그러한 이런 동기가 이렇게 있게 됐는지, 이런 것들에 대해서 종합적으로 좀 물어보셨습니다.
Okay. Thank you very much. A very good question. Hank, and I appreciate it. I was a PhD candidate or a postdoctoral researcher in the university, but as I mentioned before, I'm just thirsty for making the real thing, not a experimental approach or research. So my goal is to be a businessman or company founder. Yeah, and at the, oh, this is my old thing. Uh, I when I was see this technology, I can change change maker. 어, 그거 될 거라고.
예, 말씀해도 내가
아,
번역해 줄 수
네.
있어요.
이 시장을 확실하게 변화시킬 수 있는 기술이라고 생각했다.
Yeah, so he thought that he was quite he was quite sure about that the 3D printing technology could really change the and shift the market, and he was quite sure about it. So I think that was his motivation behind shifting his career from academic to more entrepreneur type, although he's still interested in academic aspects. Yeah.
Okay, so the main obstacle is, as you well know, the cost and money issue. At that time, 2018, I don't have any other 3D printing tech. No. At 2040, I don't have any 3D printing machines, but I just thinking, and I knocked the company for using for leasing their machine, and the main obstacle is to persuade my think to any others. Yeah, everyone. And maybe in South Korea, people already know the additive manufacturing technology, but in construction industry, they want to change their mind, and because they will this technology will be arise. Maybe he or she lost his job, his or her job, so they don't want to use this technology. So I think the most critical issue is to persuading customer or colleague. So because I did a lot of self-designed planned product myself. So and then my colleague and potential customer will be followed at the end of my presentation. Interesting. So and yeah, I think this is a very big problem, and people need it. Yeah.
Well, thank you for sharing your insights, because potentially some of our PhD students will follow your path as well and develop tools, service, methods, processes, or products through their PhD research with the idea of commercialization. And we as ArchMenu very much welcome the idea that an academic research could lead into a commercial product at the end. So it's quite interesting to see what you do. Any plans to bring your product and your research to Australia as well?
Okay. As you mentioned, the Australia and Korea Foundation, maybe the national grant will be opened the next year. Maybe I think I checked it. Yeah. So the first cooperative work will be AKF Foundation grant, and we are.
제가 설명을 해도 될까요?
Okay.
오케이. 자, 그래서 많은 박사 학생들이 이렇게 자기 쪽에 있는데, 당신의 이제 이러한 어떤 학계에서 산업이나 이렇게 사업화로 하는 이러한 것들에 대해서 흥미를 많이 느끼고 그러한 패스를 많이 따를 수도 있을 것 같다라는 생각을 했고, 또 학계가 그렇게 되는 것을 많이 보고 싶다 이런 것도 많이 이야기를 해줬어요. 그리고 마지막으로는 호주에 나중에 오게 되면은 너무 또 좋을 것 같다. 호주에서도 보고 싶다 이런 이야기를 해줬습니다.
Okay. Thank you very much.
Good. If there aren't any further questions, then there's one still. Yes, please ask the question and quickly introduce yourself as well, so we know who is speaking. If you put on your camera, that would be cool as well.
Okay, excuse me, can you hear me?
Yes, yeah.
Yeah,
Oh,
I hear
hello.
you.
Hello, thanks. First of all, thanks for your informative and very visually appealing presentation. I wondered, this great product of yours and research, have you ever considered the prospect of using something like generative AI to more automate even more your pipelines and make your products even more future forwarding in terms of the AI avalanche that is coming in our industry? It would be great if you can address this question. Thank you very much.
Yeah, let me
Oh,
translate.
very. Yeah. Very good question. Yeah.
Yeah.
Okay.
Go ahead.
Yeah. Please translate.
Okay, let me quickly translate it. So, 발표 정보가 굉장히 좋았고, 비주얼도 너무 이렇게 합리적이고 잘 이렇게 커뮤니케이트 된 것 같아서 재밌었고, 하나 궁금한 점이 있는데, 요즘 이렇게 생성 AI나 이러한 LLM 모델들, 이런 것들이 굉장히 이제 붐인데, 이러한 것들을 활용하고자 한 어떤 생각들도 있었는지, 미래 혹은 그러한 어떤 플랜이나 이런 것도 있는지, 조금 궁금해서 질문을 한대요.
Okay, very good question. Yeah, thank you very much. Yeah, AI is getting hot. Yeah, very hot potato. So, in additive manufacturing sector, many people thought about the AI technology. Yeah, the most common prospect is to okay, sorry, please translation. AI 기술을 통해서
Yes.
사람들의 생각이나 그 생각을 그림이나 글로서 훨씬 더 명확하게 표현해 줄 수 있기 때문에 이게 곧 3D 프린팅 테크놀로지의 기저가 될 거라고 생각해서 사람들이 굉장히 좋아하고 있다라고 좀 설명해 주세요.
Yeah. So let me translate this. So first of all, Dr. Yu mentioned that this LLM-based large language model and application of those are certainly a kind of a hot potato, and he's definitely aware of such emerging tech coming into all different types of field, and particular interest around this AI tech from Dr. Yu's perspective is that since many AI APIs or LLM-based model is producing and supporting visual communication in terms of generating images and dialogue. So he is actually thinking that such generative models, which mainly related to image-based aspects, are already kind of pushing the boundary of in terms of inspirations and all aspects of 3D technology or the area of the subject. So he thinks it certainly is pushing it, and he's also aware of that. But the main thing he's considering is the power of image generation, which is certainly inspiring and creating different models of construction practice. Thank you.
And then this is the surfaces. The surfaces strength point. In the more in-depth technology system, As you well know, the Rhino Grasshopper can utilize the AI LLM model and etc. So I plan to making the freeform design by via LLM texturate input the text and making the 2D image and calculate the depth of the XY plane, and can we fit the structure profiling node system or any other surface which we extracted the 3D printing path or making path, and then we can easily extract a real world product by using AI technology. So yeah, that is the very simple way to create adding value. Yeah. Is it clear to? Is it clear?
Yeah. Yeah, 괜찮.
It was completely clear. Thank you very much.
Yeah.
Thank you. All right. If there are no further questions, being mindful of time, then I would like to thank Dr. Yoo for his presentation. It was very insightful, and we're looking forward to partner and collaborate with you in the future on projects like the Australia-Korea Foundation Grant or other research projects. Maybe in the future we would be both able to see each other in person as well in the conference or the visit in either of each other's country.
예. 그래서 너무나 잘 들었고 실제로 굉장히 영감을 진심으로 많이 받았다는 뉘앙스를 말씀을 해줬고요. 그리고 차후에 어떠한 형태로든 협력이 가능하면은 또 재밌을 것 같고, 뭐 구체적이진 않더라도 그러한 가능성들을 언제나 함께 이렇게 열어볼 수도 있다 생각을 하고, 조금 더 구체적으로는 뭐 한국연구재단이나 이러한 혹은 이런 어떤 걸로 같이 도모해 볼 수도 있다 생각을 하고, 최종적으로는 차후에 물리적으로도 이렇게 대면으로 만나볼 수 있으면 더 좋을 것 같다고 말씀을 하시고 감사해 했습니다.
Yeah, I hope to meet you. Yeah, in Sydney or Seoul, South Korea. Yeah.
So then, thank you everybody for joining the talk today. We're going to keep you updated on LinkedIn, the future talk series that will come up. I think we've got a few in the pipeline coming that will be announced shortly. So keep out an eye. If you haven't really joined us yet on LinkedIn, LinkedIn Arch menu is for the best way to engage with us at the moment. So again, thank you everybody for joining today. Have a lovely Tuesday wherever you are, and thank you for participating in the talk. Thank you. Bye-bye.
Thank you.
Thank you again, Hank. Thank you.
Thanks.
Professor Lee.
Bye.
Yeah.
Thank you.